Hello students, welcome back. I am Rinkesh sir, and today we will continue with the miscellaneous exercise 5 of chapter number 5, that is complex numbers and quadratic equations. Till now we had completed till question number 9. So let's start with question 10. Question number 10. Z1 is given to be 2 minus I and Z2 is equal to 1 plus I. Let's write down. Z1 is equal to 2 minus I and Z2 is equal to 1 plus I. We have to find out modulus of Z1 plus Z2 plus 1 upon Z1 minus Z2 plus I. Okay, so now let's put down the value Z1, that is 2 minus I, plus Z2, that is 1 plus I, plus 1 upon Z1 again 2 minus I. Now it's minus Z2, so it will be minus 1 minus I and plus I. So now 2 plus 1, 3 plus 1, 4 minus I plus I, it will get cancelled upon. So 4 plus 0. 2 minus 1, that will be equal to 1. Minus I plus I gets cancelled, so remaining minus I. So I carry forward here, it will be modulus of 4, that will be equal to 4 upon modulus of 1 minus I. So this will be equal to 4 upon under root of 1 square plus coefficient of I is minus 1, so minus 1 square. So this will be equal to 4 upon 1 square, minus 1 square will be 1, so 1 plus 1 root 2. I can write down 4 as 2 into 2 upon root 2, so root 2 ones are into root 2, so this is equal to 2 root 2. Clear? So answer is 2 root 2. That was about question number 10. So just note it down. Now let's move to the next question. Question number 11. If a plus ib is equal to x plus I whole square upon 2x square plus 1, then prove that a square plus b square equal to x square plus 1 whole square upon 2x square plus 1 whole square. Okay, so let's take the given thing. A plus ib equal to x plus I whole square upon 2x square plus 1. Okay, now let's take the modulus on both the sides. So modulus of a plus ib will be equal to modulus of x plus I. I can take down whole square outside upon modulus of 2x square plus 1. Okay, this will be equal to modulus of a plus ib under root of a square plus b square. Modulus of x plus I under root of x square. What is the coefficient of I? 1 square. So 1 and this square. Modulus of 2x square plus 1. Now see, here there is no imaginary number, so it will be as it is, 2x square plus 1. Okay, so root of a square plus b square. Now here square root and square, so it will be x square plus 1 upon 2x square plus 1. Now squaring on both the sides, squaring on both the sides, I will get a square plus b square, square root and square, it will eliminate it, and here x square plus 1 whole square upon 2x square plus 1 whole square. Okay, hence it is proved This was about question number 11. Note it down. Now let's move to the next question. Question number 12. Z1 is given to be 2 minus I and Z2 is given to be minus 2 plus I. So now there are two sub questions. First, you need to find out real image of Z1, Z2 upon Z1 bar. And second, you need to find out imaginary image of 1 upon Z1 into Z1 bar. First, let's also find out Z1 bar. So Z1 is equal to 2 minus I, so Z1 bar will be equal to 2 plus I. Okay, so first let's solve the first one. Z1, Z2 upon Z1 bar. Then we need to find out its real image. Z1 is 2 minus I. Z2 is minus 2 plus I upon Z1 bar, that is 2 plus I. Okay, so what I can do, I can take minus, or let's multiply it. 2 into minus 2, minus 4. 2 into I, plus 2I. Minus I into minus 2, plus 2I. Minus I into plus I, that is minus I square upon 2 plus I. So instead of 2 plus I can write it down 2 plus I inverse, multiplicative inverse of it. Now this will be equal to minus 4 plus 2I plus 2I plus 4I. A minus I square. Value of I square is minus 1 and a minus sign, so it will be plus 1 into. We'll use your shortcut for multiplicative inverse 2 upon 2 square plus 1 square. So 4 plus 1, 5. We'll change this sign, minus 1 upon 2 square plus 1 square, again 5 I. This will be equal to minus 4 plus 1, minus 3 plus 4I, 2 by 5 minus 1 by 5. So now let's multiply. Minus 3 into 2 by 5 minus 6 by 5. Minus 3 into minus 1 by 5 plus 1 by 5I. 4 into 2, that is 8 by 5I. Minus 4 by 5I into I square. This will be equal to minus 6 by 5. Now here it's I square, that is minus 1, so it will be plus 4 by 5. Minus 6 plus 4, that will be equal to minus 2 by 5 plus 1 by 5I plus 8 by 5I, that will be 9 by 5I. So this is the real image and this is the imaginary part. Real part, imaginary part. So the real part of Z1 Z2 upon Z1 bar, this is equal to minus 2 by 5. Clear? This was about the first part of question number 12. Just note it down. Now let's see the second part of it. Second part is imaginary image of 1 upon Z1 into Z1 bar. First let's find out 1 upon Z1 into Z1 bar. Now we know that complex number multiplied by its complex number will give us the square of its modulus. So this will be equal to 1 upon Z1 whole square. Why? because z into z bar is equal to modulus of z square. So this will be equal to 1 upon what is z1? That is 2 minus I. So this will be equal to under root of 2 square plus minus 1 square whole square. This will be equal to 1 upon 2 square plus means 4 square plus 1 5 root 5 n square. So this will be equal to 1 by 5. Okay, so rearranging in a plus I I can write down plus 0I. This is the real part and this is the imaginary part. Imaginary part of 1 upon z1 into z1 bar, this is equal to 0. Clear? This was about the second part of question number 12. Note it down. Now let's see the next question. Question 13. Find the modulus and argument of the complex number 1 plus 2i upon 1 minus 3i. Z equal to 1 plus 2i upon 1 minus 3i. So I can write down 1 plus 2i into 1 minus 3i inverse. 1 plus 2i, we will use the shortcut 1 upon 1 square plus 3 square, that is 9 plus 1 10. I will change this sign to plus 3 by again 1 square plus 9 square I. And let's multiply 1 into 1 by 10 plus 1 into 3 by 10 I plus 2 into 1 by 10 I plus 2 into 3, that is 6 by 10 I square. So this will be equal to, now 6 by 10 I square is minus 1, so this will be minus 6 by 10. So 1 by 10 minus 6 by 10, that will be equal to minus 5 by 10 plus 3 by I plus 2 by I, that is 5 by 10 I. So Z is equal to minus 1 by 2 plus 1 by 2 I. So X equal to minus 1 by 2, Y equal to 1 by 2. R, that is modulus of Z, that is under root of x square, that is minus 1 by 2 square, 1 by 4, plus y square, that is 1 by 2 square, 1 by 4. This will be equal to square root of 2 by 4, so root 1 by 2, or I will write down 1 upon root 2. 1's are 2. So this is the value of R. Now tan theta, that will be equal to y by x. So what is y? 1 upon 2 x minus 1 by 2. So this is minus 1. Now ignoring the negative sign, when the value of tan is 1, pi by 4. So alpha is equal to pi by 4. Now for quadrant, for first quadrant, alpha. Second, pi minus alpha. Third, alpha minus pi. And fourth, minus alpha. Now which quadrant it is? X is negative this way, y is positive this way. So here this will be in the second quadrant. Second quadrant, it's pi minus alpha. So the argument theta is equal to pi minus pi by 4. So theta is equal to 3 pi by 4. This is the argument and this is the modulus. Okay, so this was about question number 13. So just note it down. Now let's move to the next, that is question number 14. Question number 14. Find the real number x and y if x minus iy into 3 plus 5I is the conjugate of minus 6 minus 24I. So let's take this as z. So this is equal to x minus iy 3 plus 5I. Okay, so this will be equal to, let's multiply 3x plus 5xi minus 3yi minus 5yi square. This will be equal to 3x plus 5x minus 3y. I have taken I common from these two. And I square is minus 1, so it will be minus of minus plus 5y. So this will be 3x plus 5y plus 5x minus 3yi. So this is the complex number in the form a plus bi. But now it is given that this is the conjugate of minus 6 minus 24. So what will be the conjugate of this? This will be equal to 3x plus 5y minus 5x minus 3yi, and that will be equal to minus 6 minus 24i. So now if I will compare both the sides, I will get 3x plus 5y equal to minus 6. Equation 1. And minus sign here, and here is also minus sign. So 5x minus 3y equal to 24. Okay, so now let this be equation 2. Now let's take elimination method. Multiply equation 2 by, multiply equation 1 by 5. So it will be 15x plus 25y equal to minus 30. Equation 2 by 3. So further is again 15x minus 9y, and that is equal to 72. Okay, minus plus minus. 15x got cancelled. 25y plus 9y, that is equal to 34y, that is equal to 70 minus 30 minus 70 minus 102. Y is equal to minus 102 upon 34. So I will get y is equal to minus 3. Okay. Now putting the value of y as minus 3 in equation 1. Putting value of y equal to minus 3 in 1. I will get 3x plus 5 into minus 3 equal to minus 6. 3x minus 15 equal to minus 6. So 3x will be equal to minus 6 plus 15, that is 9. So the value of x is equal to 3. Okay. So value of x is 3 and y is minus 3. Okay. So this was about question number 14. Just note it down. So let's move to the next, that is question number 15. 15. Find the modulus of 1 plus I upon 1 minus I minus 1 minus I upon 1 plus I. So let's take this complex number as 1 plus I upon 1 minus I minus 1 minus I upon 1 plus I. Okay, let's take LCM and add it. 1 minus I, 1 plus I. This will be 1 plus I into 1 plus I, 1 plus I whole square, means A square plus 2AB, that is 2I plus B square, minus. Same will be situation here. 1 minus I into 1 minus I, 1 minus I whole square, A square. So 1 minus 2AB, that is minus 2I plus B square. This will be equal to 1 plus 2I. I square means minus 1. Minus 1, or let's first leave it as plus I square. Minus 1 minus minus plus 2I minus I square upon, now this is 1 minus I, 1 plus I. Okay, so it's 1 minus I square, B square minus B square. I square will get cancelled. 1 minus 1 get cancelled. 2I plus 2I, it's 4I. 1, now I square is minus 1, so minus of minus plus 1. So Z is equal to 4I upon 2, that is equal to 2I. So modulus of Z will be equal to under root of 2 square plus 0 square, that is equal to 2. Here, so the modulus of 1 plus I upon 1 minus I minus 1 minus I upon 1 plus I is 2. This was about question number 15. Just note it down. Okay, students. So that's it for today. In our next video lecture, we'll continue from question number 16 and complete this chapter. Thank you.